So in a Hotwire application, one of the features that it offers is this concept of turbo frames. Turbo frames allow you to decompose your page into little islands of functionality. And one of the very cool things about that island of functionality is that if you add a source attribute to a turbo frame, it will defer loading of the content of this turbo frame until after the parent page has loaded. So let's actually just take this out at first. And we have our page here, and we have a turbo frame, and we have some embedded content that says frame content is eagerly loading. And if we go ahead and run this page, you can see we have our frame content is eagerly loading, but it's not doing anything because there is no directive on this turbo frame to tell it to do anything. So let's go ahead and put that source back in. And what we'll see if we refresh the page again is that we get a flash of this loading content, and then all of a sudden the content of the frame changes. And if we look at the network activity, and we look at the fetches, what we can see is that we went out to frame.htm, which is what we have here in our source. And this is being initiated by Turbo. So Turbo is making a request behind the scenes asynchronously to grab the contents of this frame, which it is then popping into our live DOM. So again, when we have a source attribute on our Turbo frame, it turns the loading of that frame content into an asynchronous operation. We're going to be eagerly loading it in this case, but we could add loading equals lazy to make it a lazy loading option, but that's not the point of this particular exploration. Now, this is great when we first load the page, but we start to see a problem when we go to another page and then go back to the home page. And what you'll see is a flash of the cached content, then a flickering of the loading content. So we go back and we see there was a flash, then eagerly loading, and then the content. Let's try it one more time. So quick flash, then that, then that. So essentially it was doing a rendering of the cached content. Then it was getting the live version of the page. The live version of the page had the unloaded frame, which it was then flashing for a second. And then eventually the new frame request came and replaced that in the live DOM. So that's pretty frustrating. It's really great that on the first render, we get that deferred loading, but going back and forth, you can clearly see that there is some visual discontent happening, right? It's a very distracting concept here to have this part of the DOM constantly flickering in and out of existence. So to get around that, what we can do is turn this turbo frame into a permanent element, and we can do that with the data turbo permanent attribute. And what that tells TurboDrive to do is take this element with this ID and treat it as a permanent element across page requests. So it's going to cache this element, and then if I navigate away from this page and back to this page, it's going to take the cached version of this element and inject it into the DOM instead of the live version. So if we get that and we refresh our home page, what we'll see is the same initial deferred loading. So we see our loading state and then our loading frame. And let's just double check here that we have that data turbo permanent attribute. And now what you'll see is that when we go to the about page and we come back, there's no flickering. In fact, the frame content has already been loaded, and that's because it's using the cached version. And we look at the timestamp here, 13:51:40. If we go away and come back, you'll see that it is still 13:51:40. So that's pretty great. So now we have, again, if we refresh, we have that eagerly loaded, deferred loading of the frame. But once it gets cached on the client side, we can leave and come back, and it's still cached. The same with the back button, still cached. So this works both for restoration visits as well for application visits. Now, it's great to have that content cached, but that doesn't necessarily mean that we want it cached indefinitely. And what we can do is programmatically refresh the content of the frame. I have a reload button here, but first let's just look at the code to see what the reload button is doing. So if we jump into our frame, and this is the fetch that's happening behind the scenes, you can see that I have a button here with an action that's calling the perm frame controller and calling reload. Now, there's no controller outlined here because this isn't actually the version of the turbo frame that's being attached to the DOM. It's just using the ID to match those values up. Instead, it's going to be using this version of the turbo frame, which you can see has this perm frame controller. So that button is going to be calling perm frame.reload. And if we look at our stimulus controller, all that's going to do is call reload, the native reload method on the turbo frame custom element. one other thing. It's also adding the snazzy class. We'll get in that in a second. But if we click the button here, let's go ahead and just look at the DOM. If we click here, you can see that it updated the timestamp and it added that snazzy class. And in fact, if we clear the XHRs here and we reload again, you can see that it is going out to frame. And again, let's try one more time. And you can see it's going out to frame and it's getting fresh content. Now, again, the cool thing of how Turbo works, or how Hotwire works in general, is that it treats the DOM as this source of truth. So now that I have this snazzy class on the Turbo frame, if I then go to the About page and I come back to the home, you'll see that that restored permanent element still has the snazzy class on it. And that's because this is the state of the DOM that gets cached when the page is unloaded. So very cool stuff. Now, if we look at the console here, you can see we have some stuff getting logged, and that's the thing I want to look at next. So if we look back at our stimulus controller, we have a couple of lifecycle events. We have our initialize, and that's essentially when this class gets constructed. Then we have our connect, which is when our instance of the controller gets attached to a host DOM element. And we have our disconnect, which is when the controller gets detached from the host DOM element. So let's navigate across pages and see what happens. Let's just refresh to get the most up-to-date content. And you can see our controller is initialized, and then our controller is connected to the DOM. That all makes sense. If we reload, we don't really get any stimulus lifecycle events because the controller didn't change. All we did was change the content of the frame, but the frame itself, from a lifecycle standpoint, stayed pretty much the same. What gets interesting is now when we leave, we can see the disconnected, which makes sense. But when we come back, watch this. We get our controller initialized, then our controller connected, then disconnected, then reconnected. So what's going on here? First, we can tell that when a page is rendered, even if we have cached content, the stimulus controller instances are not cached, which means that stimulus is reinstantiating our controller every time a particular DOM element becomes available for the first time. Then it gets connected, and this is the preview version of the page. So the way that TurboDrive works is it attempts to render a preview of the page if there's one available, and then we're connecting to the preview version. Then it goes to the server, gets the live version of the code, and swaps it into the active DOM. At that point, we disconnect the preview version, and then we take that same stimulus controller instance and we reconnect it now to the live version. So while the controller instances are not cached across page requests, we can see that within an individual page lifecycle, controllers are only instantiated once for a given DOM element. And that's why the same controller instance is able to be connected twice between the preview and the live view. And the subtle inference here is, again, that Hotwire is aiming to treat the DOM, or the document object model, as the source of truth. So whereas with something like an Angular application, where we might cache state in the services that get persisted in the application state, Hotwire seeks to cache state in the DOM because the DOM is persisted, whereas the service layer or the controllers are not. So again, just a lot of subtle, interesting details here, but this is pretty cool, I have to admit. We get the benefits of that deferred loading, and then we get the benefits of client-side caching, and we get the benefits of being able to programmatically change that cache as we seek, as it becomes necessary. So it's been hard for me to dig into Hotwire coming at it from an Angular application mindset, but then I keep uncovering little details about the Hotwire framework like this, and it's very exciting. I'm starting to see a lot of the potential here in taking a multi-page application and turning it into a rather responsive single-page application experience. So just very exciting.